Okay. Well, thank you, random voice in the air. All right. All right, so hi everyone. For those of you who are watching this later, I am Chris Lai. I am the president of CPB Hyperloop, and today I'm going to be talking about screws and tolerances. Now, I'll be really honest with you. I only learned about how to use screw and tolerances really well 6 months ago. But in those 6 months, I have learned that screws are really hard to deal with sometimes, but you can get around the hard part of it by simplifying a lot of things. And B, I use screws a lot in some of my projects, so I'll be just demonstrating that today. And it's a really nice way of joining things together. Oh, that's the wrong screen. Okay, so really quick, types of screws. Now, I'm going to go overload you with some information here about screws. So generally, there's two types of units of measurements for screws. You have your imperial screws and your metric screws. Right? So this just says how screws are measured. In the world, we have us, America, we use imperial, and then we have the rest of the world, which uses metric. Some other countries use imperial, but most of the world uses metric. So it's really going to be fun when you go ahead and try to design a project and you buy some cheap Chinese knockoff of something off Amazon. And it turns out that cheap knockoff has parts which you need metric screws to screw in. And so by doing that, you pretty much essentially have to use metric screws. However, if you're designing something for yourself and you want to manufacture it in the US, usually they'll prefer imperial. So right off the bat, we have a lot of confusion happening on when you're designing something. You want to make a project or anything. But generally, there's only two types of screws or two units of measurements. That's the umbrella part of it. Next, we go into hole type. For hole type, there are, this describes the hole that you're going to drill the screw into. You can either have a flat or rounded hole. You have a countersink hole, which kind of looks like the V shape you see in the diagram. Or you have a counterbore hole, which looks like a rectangle. So you can barely see it, but it's like a rectangular shape right here. And so it depends on which screw you have. If you look at the data sheet, they'll have exact dimensions for the countersink angle, because this angle will vary depending on which screw you have. And the counterbore, you basically measure with a dial caliper. So, for example, I have a bunch of screws here. These screws are imperial screws, and these are flat-headed, but I have more screws. These screws have a countersink too. So if I open these up, you guys can get up and take a look at this if you want. But the screws that are countersunk have an angle to them. And I'll show the camera. You can kind of see the angle. So when you're drilling this into a flat surface, the angle might stick out, right? So when you're designing a part for something, you want to make sure that your part has the angle that is a hole, so it slots in nicely. Otherwise, you're going to have the screw stick out. You don't have this problem with a flat rounded screw because it has a flat top to them. So you see the flat bottom part. You can just drill this into a flat surface, and it will be flush, or if not, just a tiny little rounded edge above your surface. Now, this is where you can use a counterbore hole, because if you use a counterbore and you just put a little lip on the inside of this, you can screw this all the way in, and the screw will be flush with the surface. And what I mean by flush with the surface is that when you drill this screw in to whatever you're manufacturing, you shouldn't be able to see the screw, or it shouldn't make a vertical height difference after you put it into your brick or whatever you're printing out, right? Or whatever you're manufacturing. More types of screws. Okay, so when you're ordering screws off Amazon, McMaster-Carr, whatever, right? It's going to give you a whole bunch of options. You're going to choose drill points. You want flat or tapped screws. I only have flat screws here. Flat screws are the one with the flat bottom, and tapped screws are the one with the pointy bottom. So if you tap them, it might hurt. And tapped screws are useful because you can drill them into wood. If wood, you don't have a pre-drilled hole, it goes really in because it self-drills into the hole. Flat screws are used for joining two parts, 3D printed parts together, because usually you won't have a point to drill into. Usually if you use flat screws and you manufacture the part yourself, it becomes more accurate because you don't have to drill something in. If the hole's already there for you, this is the wrong category. If the hole's already there for you, then it's really easy. But if it's not, then tap screws are the way to go. So If you're manufacturing something with wood, maybe acrylic, or something you buy at Home Depot, use the tap screw. Otherwise, if you're just 3D printing it, you want to join two parts together, you can use a flat screw. Drive style. How are you going to screw the hole in, or how are you going to screw the screw into your whatever you're printing? So you're going to maybe need specialized screwdrivers based on the method. The two most common ones are like the Phillips one, so like the plus shape. Here's a Phillips one. You have a flathead, which is the slot in, or you have hex. So hex is like the one from 3D printers. If you have a 3D printer and you want to screw something in, sometimes it has a hex cap. And one of these screws does have a hex cap too. Now I like using hex caps because they're more secure to drill in. But the very big caveat about using a hex screw is that they strip. So when wires strip, that's not a good thing because you can't get them out. So don't tighten them too hard, Material and finish. This doesn't really matter for our purpose, but if you want your screw coated with some kind of like metal or some kind of any one of these ones on the right here, you have black anodized, black epoxy, black oxide, there's a whole down list. This doesn't really matter for your purpose, but unless you want to get really specific about what you're using this for, you can use that. Material, you can have a bunch of screw materials, aluminum, brass, bronze, carbon fiber, etc. This only matters if you are worried about the structural integrity of your screw. Like you can just use a generic one for your project and it'll be completely fine. The final one I have here is thread size. So thread size is really important because if you're designing something like in Fusion 360 and you want to know, how to drill a screw in after you print your part on your 3D printer, you want to know how many screws are inside your screw model. And in a little bit, I'll go over how to make a hole that has modeled threads in Fusion 360. You can actually print these out, and they actually print out pretty well. And if you're manufacturing the parts and you want the manufacturer to include some kind of threaded hole inside, you need to tell them what thread screw you're going to be using. So that's also really important. So that was the overload information. In general, though, I've only used like two basic screws, right? And the two most basic screws we're going to be talking about today are the 8x32 and the M2.5x6. And so we're going to go over screw types and how to analyze them right now. If you go on Amazon and search screws, they're going to give you a list, right? You kind of need to specify, what screw you want. You want inches or metric, and then what kind of length of screw do you want? What size do you want? What the head style, etc. So what does this all mean? Well, if you're going to move on to some, engineering stuff, and you see people label the screws something like this. So this is a number 8x32 times 1/2. What does this mean? Well, the number 8 for imperial means the diameter of the screw. Now, us Americans are weird, so we kind of we don't put a measurement here. You gotta look at the table. So there's actually a good calculation for this, but I'm not showing you. Just look at the table. The table says number 8 has a decimal or thread diameter of 0.164, and to the nearest fraction is 5/32. I don't like the fact that it says nearest fraction because that can mean a lot of things, right? It's not precise. And usually if you measure a screw with a caliper, it's not precise. So number 8 means the diameter of the screw, right? You look at the diameter table. Yes, Annie.
Is that the diameter including threads or not
including threads? Not including threads.
Okay.
Does that mean that the diameter that you need to use for all the stresses calculation? Because when you're calculating stress, you're using, I don't remember the name, it's a specific diameter. It's not it's I think halfway between the highest diameter, the largest, and the smallest, considering where the thread is. Is that one?
It's the inner diameter. It should be without threads, but I think this little bigger. But in general, it's number 8, right? Imperial screws, I would say you're using for bigger applications, usually not the smaller applications. Those use the metric screws because they're more precise. That's the reason why in my cabinet I carry more metric screws than imperial, just because I'm an electronics guy and I work on a lot of electronics. And the smaller ones are usually more precise, right? The bigger ones are for if you want to jam something into wood. The next number, which is 32 in this case, is the TPI or the thread pitch. TPI stands for thread per inch. So the number directly corresponds to TPI, so 32 threads per inch, right? So how many of those revolutions are there in 1 inch? Let's say. The last number, 1/2, is the length of the screw, which is a 1/2 inch long in this case. And this is probably the one that's going to vary the most, varies depending on what you're designing this for. So basically, how it's usually, you can usually buy this on Amazon, is you look at the first two numbers, right? That says what type screw it is. 8x32 is very common. You can also have number 6x32 or 10x32. You can also have like 10x24. So diameter, threads per inch. And then if you buy on Amazon, they usually come in kits. So the kits have varying lengths. It's like kits like these, right? I show the camera. So you can buy kits like these. This one is a number 8x32 kit with varying lengths. And so you buy one of these and you're basically set for whatever purpose you're doing this for. Of course, if you want to go ahead and use some other types of screws, as long as you know the screw type you're buying, you can probably search it up somewhere. And they do sell it in packs of like a single screw for like 100 of them. And I'll show you how to get to that later. So here's another example of a screw. So we have a number 10x24, and it's 5/8 of an inch long, right? So number 10 is the diameter of the screw, like the inner portion. Number 10 says it's 0.190, and to the nearest fraction is 3/16. We have 24, which is 24 threads per inch, and 5/8, which is 5/8 of an inch long. Pretty simple. So no longer will you be confused by looking at this on like a drawing. Yes, sir.
Is the, how to explain it, the length of the threads, is that standard?
Well, that varies. So depending on the kit you buy, this length of screw.
No, the length of the thread, I don't know how to explain it, like, the amount the thread comes off of the main screw.
I think that's standard, yes.
Okay.
So it's standardized by. Should be the same. You can find it in a table out online somewhere. I saw it in PowerPoint. A good question. Okay, metric screws. Let's complain about metric now. Actually, no. I really like metric better because look, it's really easy. M, which stands for metric, and then the number comes after it, right? That number is the exact major diameter of the screw. No number 8, number 6. Yeah, that's confusing. M2.5 means that the screw diameter is 2.5 millimeters, right? The 6 stands for length. So length is 6 millimeters. Sometimes you might see an additional number after here, like M2.5, like -5 or something. That just stands for the threads per inch. But usually for metric, they're standard. If you buy them off Amazon. So you don't have to worry about that too much. But metric is usually more simple because it's more exact and it's used for smaller applications. So you see on this table here, we have like M1.6, M2. Anything like around this region is used for computers because a lot of computers are built in China, right? So if you're putting it together in here, you're going to need some metric screws. Most of them go in China. The bigger ones, you have M20s. These are like huge screws. I've never seen one. I've only gone to M10, and those are already really large. M10 means that has a major diameter of 10 millimeters, just 1 centimeter. Those are pretty thick screws.
Chris, are you sure that 6 is the length and not the pitch?
Yes, it should be the length.
I'm sure about that.
The length, like this?
No, the pitch, the length in between the threads. Because 0.35 with medium means that thing is super small. So it would be 1.6 by 0.35 millimeter. So it would be a really small thread. But if it's a pitch, which is the distance between the tip of the threads, that would make more sense.
I'm pretty sure that's the length because like this one would make sense because this one is like this is a very small screw. The screw I have in here is an M2.5 by 6.
Yeah, but a screw that is 0.35 millimeter long. That's really small.
Yeah, I know. I don't know why it's like actually that small. This table might be saying something different. Yeah.
The table is showing the diameter and the per inch.
Yeah, it might be that. But like this is usually the way you see them on Amazon.
Okay.
Sometimes you
Yeah,
Okay,
6
so
is the
everyone-
length.
Sorry, what was that, Ben?
6 is the length.
Right. 6 is the length as I said it here, but on the table it says something different.
It's the top side.
Mm.
Yeah, that's the top size. So I'm just gonna do a quick
Tap is the thing that you use to thread.
Yeah, to make the thread. That
Okay.
makes more sense.
Okay. We're gonna just get rid of this table and pretend it never existed. All right?
Editing on the fly.
Yeah. So, but 6 is the length. I'm pretty sure about this because like I organized all my stuff by the length. yanking all those data off like a random Google link probably wasn't the best idea.
No, that's perfect.
Yeah, but it's fun because like that's what we're here for. We're here to learn. All right, McMaster-Carr. This is where you find all your cool little screws, and you can find the step files for them too. It's really cool because you can actually put the screws into your 3D design, and then you can like put them into your model. So let's go ahead and learn how to navigate McMaster-Carr. Okay, let me copy the slideshow for Van so Van can see it. I do put the PowerPoints in with the video description too, so.
Gotcha. Thanks.
Okay. So McMaster-Carr is a very cool place where you can buy screws, but we never buy screws there because the shipping price sucks. Yeah, shipping sucks. Amazon's free. Okay, so what we use McMaster-Carr for is finding step files, right? That's the best part of it. So let's go to screws and bolts. And basically whatever screw you want, you can find it here. They categorize everything, and I pretty much took screenshots of them and put it on PowerPoint. So we're gonna look for an 8x32 screw, all right? And I'm gonna look for a button cap because that's the screw I have in front right now. So you can go and use, let's say 8x32 as inches, or because it's imperial. And then we go to thread size, we see 8-32. We're gonna look for that. And then I'm gonna go down to head type, and I'm gonna say like rounded, because that's the screw we have. And you see the rounded ones usually have a hex cap to them. Usually, some of them don't, but usually. So we see them. McMaster-Carr automatically sorts it for us in 2 sections. We have hex drive, we have filter rounded. And so from there, you can basically choose like which one you want. It all comes down to like the shape and the material from there. But I'm just going to choose the first one, which is stainless steel. Okay. Once I choose that, next we're going to pick the length, right? Because it sorts it out by length. There's a lot of different parameters you can sort this out by. And so, what length of screw do we want to get?
1 inch.
1 inch. I heard 1 inch. 3 inches.
Yeah.
You know what? Just for the step file, I'll do it. All right.
Yeah.
In Hyperloop, though, we usually use 1 inch screws, 8x32s, just to get like a lot of pieces put together. It's like one of the bottom parts actually has a lot put together. I'll show next. So let's go with 3 inches. So under here, when I click on 3 inches, we see the manufacturing number, and then we can see this screen's like really crappy. You can see a CAD file down here under product detail. So we can go ahead and, okay, you see here we have SolidWorks. Like the people in person can't see it because the projector sucks. But 3D models you can choose from SolidWorks or Step. SolidWorks is by default just change the step and then download. And then it'll download this into your downloads folder. Okay, gave it to me as a SolidWorks file anyway. Okay, now I'm going to open up Fusion 360. And then let's say I want to put the screw into some Voltex too. Why not?
Yeah. 3 inch screw into that.
Yeah. 3 inch screws are fun, huh? Downloads, then upload stuff. So in Fusion 360, what's really cool is that it automatically translates the file from step file to Fusion 360 file. So all you got to do is press upload, goes ahead and uploads itself, and that's pretty much it. And then it puts itself into a file, and then you can import it into anywhere you want. Right? Well, it's called a derive in Fusion 360. Just give it a second though. My computer is pretty slow.
I want to clarify something. So
Yes.
the diameter of the screws should be from the outside of the thread.
Is it
Should
from
be
the outside?
measured. It should be measured from the outside of the thread, not the inner part.
Nominal diameter.
Okay.
Yeah, that's the diameter.
Big
Yeah.
diameter.
Okay.
Okay.
Gotta think, I gotta think about it, because like I've measured a lot of screws in my 6 months of projects. I'll trust you guys on that. There's few people saying
Let me
that.
learn this from my Tuesday manufacturing. It's the outside.
Okay, it's the outside. Gotta clarify that later. It is the outside.
It is, yeah.
Okay, now it's done. Cool. So we have ourselves a 3-inch long 18 by 32 screw here. 8 by 32. It's 18 by 8. That's the part number. Yes, right. 3-inch long screw.
No, I have many at home, so,
You have a 3-inch long screw at home?
yeah,
You through.
I use it.
These were for wood, maybe.
Just use it to like put it on the wall. Okay,
It's like 2.5.
yeah.
Use
So,
it.
so from here, if you want to put it into like a 3D model for manufacturing, all you gotta do is right click and press insert into current design. But I'm already on the design itself, so I don't need to do that. So let's make something to put this 3-inch long screw inside. So in Fusion 360, I'm going to teach you guys how to make some holes now. It's really easy and simple to make these holes. So I'm going to make a 1-inch square as a sketch, and then I'm going to extrude this by 3.5 inches.
2 by 1 inch.
No,
Through hole.
I'm not going to make this a through hole. This is for a point.
Uh,
And then on here, I'm going to put a point. For Fusion 360, you kind of want to put a point here because then you can use the hole function. And this is really easy because all you got to do is just click on the point, and then it brings up this little menu that I can't access because the zoom thing is in the way. Okay. So this little menu is very useful because it has a lot of different options for you to make your hole just right for your screw. So on McMaster-Carr, we went ahead and said that this was an 8 by 32. So I'm going to go ahead and say this is a simple hole, which is a hole type, and the hole tab type is going to be threaded. Now by default, it gives you a simple hole. Now this simple hole does not have any threads in it. So if you want to make some, a connection for your screw, like maybe a hole to put your screw through, so that you can screw something on the other side of that, you want to use this type of hole. But for now, we're going to use tapped. Now, we're not going to have a thread offset, and we're going to make this drill point flat. If you have a tapped screw, and you want to make this easier on yourself, you can also make the drill point angle points, so that there's an angle on the bottom. And this is used for your tapped screws because they're pointy. So if you can see down here, there's like a little point now. And this point has also a parameter you can modify. So let's say your point is currently at 180 degrees, but you can make it like 135 if you want to. That's completely fine. But this angle goes from one side of the angle to the other. So it's centered in the middle. Okay, but we're going to use a flat because the thing that we got, the screw that we got has a flat bottom, right? As you can see here. Now, say we want to print this little rectangular prism out. That'll be completely fine. All we got to do is make sure that the threads are the right size. So if we go down here, our thread type is currently set to ANSI unified screw thread, which is the right type of screws. If we want metric, then we use ANSI metric and profile. ANSI stands for the American National Standards Institute. You got that right? Yeah. Acronyms. So ANSI unified screw threads, the size we're going to use, hold on. So it says the sizes for us already from like number 0 to number 12. This is a number 8. So we're going to select number 8. And this is also 0.164 inches. Okay. Next, we're going to go ahead and set our designation to 8 by 36. Even if it's an 8 by 32 screw, select this one because it makes your hole larger. And why do we want that? If we're going to print this little rectangular prism out on our 3D printer to screw this 3-inch long screw into, then we want the hole to be as large as possible, right? And PLA shrinks after it's done being printed. So if I change between 8 by 36 and 8 by 32, you can see the diameter increases slightly from 0.135 to 0.138. This may not make much of a difference now, but once you're printing it, it makes a huge difference. It basically makes a difference from screwing it in nicely and taking like almost an hour trying to like press fit it into your design. It's like from experience, save you the effort, go with a larger size. Class 2B is fine, right-hand direction, and then select model. This is a very important selection because the 3D printer is going to be able to print the holes for you or print the threads for you. And you can see them here. So the threads are now modeled, and we can stick this really long screw inside the hole. And how do we do that? Well, we need to make these into components first, like so. And once they're in components, then we can joint them together. Say put this side into the hole. It's a little off, but that's fine. Just insert it in. Okay, good enough. So now our screw is inside our 3.5 block long object. Voila. Now there's more applications to this, of course, but such as, let's go to our Hyperloop pod. Our Hyperloop pod has a lot of screws in there. I gotta go ahead and select it all. So this is the entire pod without the cover on it. And we can see here that we have a lot of screws. This one is just pressed into like 4 different layers. This is an 8x32 screw that's 1 inch long, and it goes all the way into this triangular prism. So as you can see, it traverses through a lot of different PLA layers until it gets to that point, right? So not all the PLA layers have the threaded prints inside of them, because that would be really difficult, right? So instead, what we have in these parts is we have a hole that is larger than the screw itself, but not so large that it goes all the way through. Because each screw has like a little head to them. And so you want to design it so that's like slightly smaller than the head. And I think that's what we're going to go through next. So I'm going to come back to this design, but we're going to go back to the PowerPoint. Okay, one more time. So the nominal diameter is outside of the threads. Okay. That I need to remember. Okay, where to buy your screws? Amazon. I don't recommend them buying from McMaster-Carr unless you need a lot of them. Like if you're making a factory with a lot of different screws. So here are the links. I'll send them to you afterwards. This is basically like all I bought for Hyperloop, by the way. So these come in packs, or you can buy them in like each of them. So these M2.5 by 6 millimeter screws on Amazon come at a pack of like 100 for like $6-7. Now McMaster-Carr sells them for like about $1 cheaper, but then you have shipping price of like $7. So that's the comparison. If you don't know which screw you want, and you want just a wide variety, go with these links on the bottom here. You have the good for repair, small electronics, you have larger inch screws for projects, and you have imperial screws. These are the 8x32 ones I bought that are in front of you right now. These are all pretty good. Remember that you have either your Phillips head or the hex socket, and those are good if you have the screwdrivers for them, right? And I have them for you right now. However, for a hex socket, just make sure you don't accidentally strip, because these are pretty cheap screws. So if you're like just forcing it into something, that's probably going to strip it, and you're probably not going to be happy. Now, otherwise, if you treat it nicely, it'll treat you nicely as well. And of course, McMaster-Carr, if you are doing some large scale project, like for example, this product right here, I'm selling. I'm not going to advertise to you, but like I have it here right now. If I want to make this into a wholesale product, right? This is the sound Voltex box. Then I need a lot of screws of the same size. Then I would need to buy wholesale, and McMaster-Carr would probably be better for me. Otherwise, if I just want to test something out for prototyping purposes, Amazon. This is the same thing for PCBs, by the way. Except Amazon does not make custom PCBs. So then you gotta have to buy them from JLC PCB. and the shipping becomes real expensive. Oh, thank you, everyone. I forgot about this. Okay, holes. We already did this, but this is a hole. Nice large picture for you. You create it from a point in a sketch, and I do Fusion 360 for all this because that's the only CAD program I know. I also know Inventor, but I don't use it. This is by Josh. So I create a point in Sketch, use the whole operation in Fusion 360. Select your parameters, adjust when needed, done, right? Your parameters, you can have flat, countersink, counterbore. You can have threaded or smooth holes. If you have threaded holes, make sure you model the threads, account for tolerance, and watch out for through-hole screw inserts. And so the through-hole screw inserts, I don't know what the official name for it is, but if you're designing something, you know, like a PLA part or a 3D printed part, you're gonna put a screw through it to screw in something on the other side of the 3D printed part. You're gonna need through hole, or like just like a loose hole. No, you want to call it that way. Okay. Hyperloop standards. Josh has been asking me for this forever. Please. This is the Counterbore standard that we use for Hyperloop. For an 8x32 inch screw, not 8x32 inch, 8x32 type screw, we have a counterbore hole of 0.25 inches thick. Now, the length depends on what you're using this for. So this is going to change. But if you want a counterbore hole, then the diameter, the outer diameter of the counterbore is going to be 0.325 inches. Right? This is going to allow your screw to directly fit inside and be flush with the surface. Your height is going to be 0.127. So this is how far down the screw is going to sink into your design. And then you can cover the top of something. This is the height of the screw. Now, you want your design to look nice and make it look like you didn't screw anything in. It's just magic. This is why you do it. Right? And your screw diameter is going to be 0.2 inches. Now, who here remembers the diameter of a number 8x32 screw?
0.162.
Yes, 0.164. So this is actually larger than 0.164, right? So our screw is going to go right through here. This is for if we want to attach something. So like in this example right here, we're not screwing this screw into this bottom piece, right? We're not screwing it into the fork. This is going to go all the way through into the triangle prism. So when we're designing the fork, we're going to use this type of screw, like the through hole, the loose one, right? We're not going to put threads into the, we're not going to put threads into the fork. That piece is called a fork, by the way, for non-Hyperloop members. Okay. Oh, by the way, back to this for a second. I didn't put the threaded version of this because you can basically automate it with like the thread option. Pretty much the same. The only standards you need are the ones for the loose hole. And I have the one for sound voltage too. I use 6x32 screws instead of 8x32 because it's slightly smaller and my board isn't that big. And so here we can see the loose hole, right? And we can see here the threads that go on the bottom. So loose, threaded, loose, threaded. If I have a screw, I have a bag of screws here. And I'm attaching this top piece to the board. I don't want to screw the screw into this piece and then into the board. So what I did was I made this hole a lot looser so it goes right through. Right? I can dump this out if I want to. Not the hammer screws this too. Okay, then I will go ahead and when I assemble this, I can put this on and then screw it together. And this top piece will stay in place, right? That's the difference between loose holes and threaded holes, right there. And then here are the standards if you want to reference them later, your design. In general, you should be only using like 1 or 2 different types of screws. Keep like 1 metric screw as your favorite and 1 imperial screw as your favorite. Because like there's a lot of different types of screws out there. So if you're just beginning with this, it's going to kind of get complicated. Okay, M2.5 6. This is my favorite metric screw of all time because it works both PCBs. If you want Raspberry Pis, PCBs, those all come with like nice little 2.5x6 standard screws. You can see here that this is just like the default threaded version of those. But I have here some very nice silver M2.5x6s. These usually come like in black, the different finish. But these are really nice because you can screw them in. There's like 4 holes in here for the PCB mount. And the PCB is also designed with like the through holes in mind. So you can put them all the way through. And this is like a loose, right? The loose hole. Because it goes all the way through the PCB and it doesn't screw into it. So if I put the PCB into the cover, then I can screw this in and it will hold the PCB in place. But I don't need to screw it into the PCB, right? That's like the difference we're going to make with all manufacturing kits.
Wait, so you're screwing it into the other piece, not the piece?
Right. So the PCB has a loose hole that's
And the other
bigger.
one, the bottom one has a thread one.
Yes. So the distinction between loose holes and threaded holes are very important. Yeah, we can't really realistically put threads into the PCB, right? So if you want to make your own standards, right, this is what you do. First, you determine what you're going to screw it into. If it's a 3D printed part, you want to use something called a test block, which looks like this. So it's just a small little block with a hole inside that you print out. And then if you can like screw it in the test block, you succeeded. There's your standards, right? Just write that down. If you want to use a caliper and measure the screw yourself, usually there's like some tolerance that goes into it, right? And so if you want to make a custom loose hole, this is how you do it. Just grab your caliper, put it across the screw, and then just like open it a little bit, because that creates like a loose fit, right? And remember that when you 3D print something out, PLA shrinks when it cools. So the real diameter is always going to be like a couple hundredths of an inch shorter or smaller than what we originally designed for. So really important to keep that in mind. PLA shrinks after it cools. I've 3D printed so many things and they haven't fit because like the tolerances aren't enough. But there is a threshold, so you gotta find like a sweet spot. Digital calipers aren't that expensive on Amazon. You can probably Google one and find one in like 3 seconds. They should all work the same. Recommendations probably like the second or third one from Amazon. So the first one's always like bad, like sponsored. You guys know how like they have like bots now commenting on like Amazon links saying that they're really good, but then they send you a piece of crap. Yeah. So just watch out when you're buying stuff from Amazon. But the same part is use a test block. So countless times I've told my team that when you're designing stuff and you don't know if it fits and you have a lot of the parts for it, you want to design a part of it first. So like in the pod, let's say for the dual wheel clamp. Right here. So the dual wheel clamp has a lot of components that fit together, right? It has the wheel, it has the support wheel, it has these screws, it has these screws. And so if I know, right, what dimensions I'm going to have, especially for these screws, because I have them standardized, I can immediately design them for it. Now I don't have to test it. But however, for the wheels, I don't know if I'm going to be right. And this piece takes 8 hours to print, right? So for example, like the little screw holes in the back, I didn't know which dimensions those were. So I have little pieces that just allow me to screw the motor in, just get the motor dimensions right. Those little pieces take me like 30 minutes to print out, compared to 8 hours, right? So if I have a bunch of 30-minute pieces, I'm fine with that. But I don't want to like print one of these out in 8 hours and have it be a waste. So use test blocks or test pieces when you're designing stuff. It's really helpful. Oh, that's it. What time is it? Any questions? Cool. I think this is the part where I start making the people in person assemble my board for me, because that was the in-person portion of it. But I'm going to stop the recording here. Thank you so much for staying and listening if you have, and I hope to see you in the next workshop. Bye, guys.